Hello and welcome back. Coming to you from our downtown studios at a busy intersection. And today's topic is correlation regression. This is presentation 10.3, part of a multi-part series in statistics. And you can see here the material contained in your textbook and workbook. And we want to acknowledge the development team of Brad, Spencer, and Amanda. We've chosen for illustration of this material the notion of predicting a house price on the basis of the area. And coming on the screen here, we can see the graph of the price versus the area. The area is the independent variable. The price of a house, is a dependent variable because we're using the area of a house to predict the price of a house. And we can see here there is a trend line upward. As x increases, the y will tend to increase. Now this is the Excel output. Multiple regression, multiple R means this is the Pearson coefficient of correlation, that values between -1 and +1. The R-squared value of 47.01%. And we're suggesting 47.01% change in the house price can be associated with or attributed to the changes in the area of a house, not to suggest cause and effect necessarily. And here's the graph. Assuming a linear trend, linear equation, that's this line here, we have that the B0 and B1 are estimates of the population parameters, beta 0 and beta 1. We're assuming normal distributions here. And we find that from the Excel output, the values are all given here. This is our slope. This is our intercept. Putting those into the equation here now, we have this is our regression line. It's called the regression equation, or the least squares line, which we'll talk about later. And the slope, delta y over delta x. This ratio here, 226.16. And this suggests when the change in area is 1 square foot, the delta y becomes 226. This represents the average price per square foot for houses in this region. Best prediction of price using our model, we simply take x equals 2.2, substitute in this equation, giving us the value 539.98, and that corresponds to the point here on this graph. We're going to do a statistical test of the slope, which is equivalent to a test of correlation. And there it is on the screen. We're going to switch to a new screen here. The slope of the linear regression line is not significantly different from 0. Beta 1 is 0, equivalent to the correlation coefficient, the correlation equal to 0. And here we have the regression line slope not 0. And again, we're just doing a test of this one parameter. The distribution of slopes, B1 samples, has n-1, n-2 or 13 degrees of freedom. And we lose another degree of freedom here because of the fact that we're observing these two variables at the same time, which represents a constraint. Follows the t-distribution. And at alpha equal to 0.05, this becomes our criteria. And this is our test statistic up here, which we're going to look at the evidence, the observed minus hypothetical from the Excel output. This is our observed. This is our standard error. The ratio here is the t statistic, which is coming on the screen here now. We note that this is quite a bit above 2.16. So we're going to reject H0. The p-value, 0.0048, is less than 0.05. This constitutes sufficiently strong evidence against H0. Looking at the confidence interval, we're observed plus or minus t critical times our standard error, which is coming on the screen here. And that gives rise to this interval, which we see on the far right here. And we're going to suggest that this represents the differences we have here, this difference in the heights of these triangles when delta x equals 1. This region here becomes our confidence interval. And this overall suggests that the model we have is fairly good at predicting house price on the basis of area. And now for those of you interested, we can go to a multiple regression model where we include the number of bedrooms, the age of the house, bathrooms, locations, and garages, and so on. And we get a much better, accurate picture. And that constitutes into presentation 10.3. We ask you to review the details and then go to 10.4.